Hello and welcome you all in the course of Probability and Statistics. I am your instructor Hardeep Joshi. Today we should learn about some more example of normal distribution. But these are not the repetition as we have to study in our previous lecture. That is some different thing. So what is that different thing? We have to see. So we know that the total area under the normal distribution curve is equal to unity, that is 1, and the percentage distribution of area under the normal curve is given below this graphical representations. The middle line is known as the mu, that is the mean average value, and now from that the middle line just shift from left hand side as well as right hand side, that is the particular interval mu minus sigma to mu plus sigma. Now that area covers the approximately say 68.27, that is roughly we have to say that 20.68 area of the normal distributions. Then we have to consider say some more interval on left as well as the right hand side, that is mu minus 2 sigma to mu plus 2 sigma, that is approximately cover say 95% area of the Z distribution. Now in the last, the white interval, that is mu minus 3 sigma to mu plus 3 sigma, that cover approximately say 0.99, that is 99% area of the Z distribution. And we have to assign a coordinate axis. So to cover this 99% area of the Z distribution, the coordinate cover on the x-axis is say minus 3 to 3. So the maximum range covered by this x coordinate on the real line is minus 3 to 3. So if we are interested to find out the probability of x lying within this particular interval, say minus 3 to 3, then directly we have to see the value of that particular x distribution in the standard normal table. But the problem arises when the value of x is exceed this interval, that is beyond the interval minus 3 to 3. If we are interested to find out the probability when x is greater than 4, when x is lying between say 10 to 12, when x is less than negative of 5. Now we conclude that if the continuous random variable x falls within the interval say minus 3 to 3, then directly we have to take the value of that distribution, that is area under the curve, from the standard normal table. So more precisely we have to say that in this today's lecture we have to see if the value of x is not fall within this interval minus 3 to 3, then how we can find out the probability. So when x is exceed the range minus 3 to 3, at that time we have to use the transformation and say namely Z transformation. So the graphical representation is just like this. The left hand side is represented just like say x plane, and we are interested to find out the somehow probability on that particular region. So what we have to consider, when x is not fall within the interval minus 3 to 3, we have to apply the Z transformation to convert the x plane to the Z plane. And now these are the fixed transformation. This cannot be vary from example to example. This transformation is fixed whenever x doesn't fall in the interval minus 3 to 3. So the Z transformation is equivalent to x minus mu upon sigma, where x represents, that is you have to interested to find out probability for which particular value of x. Mu, that is mean, and sigma is the standard deviation. ultimately we have to say that this transformation gives the guarantee to fall the random variable x when we have to transform into z plane. So the value of z must be fall within the required interval, that is -3 to 3. And again we have to take the help of the standard normal table, and directly we have to assume or predict what is the probability of z when z is falls beyond the interval -3 to 3. So let's see the example. Now this example tells that the average daily sale of 550 branch of any particular office. Our interest is not, or our concern is not what is that particular office and what they have to sell. Just we have to consider the rough data. The average daily sale of 550 branch office was rupees 150,000 and the standard deviation is rupees 50,000. That is, the question tells that the daily sale of any of the particular office is 150,000, but it may be possible there is some decrement, that is sale is decreased or sale is increased, but how much, that is represented by the standard deviation. Standard deviation is nothing but how much data is deviated from the actual mean. So it may be possible, say any particular day the sale of office is 150 plus 15, that is 165,000. Or it may be possible, say any particular day the sale becomes say 150 minus 15, that is 135,000. So these are the range 135 to 165. Assume that the distribution to be normal. So also question suggests that the sale given by this office is follow the normal distribution. Indicate how many branches have the sale between the first option, say rupees 1,25,000, and the second one is 1,45,000. So we are interested to find out how many branches have the sales between this particular interval, that is 1,25,000 to 1,45,000, and the second option 1,40,000 to 1,60,000. So one by one we have to deal with each of them. But first of all we have to collect whatever information given in the question. So the solution or definition tells that given that the mean, that is expected value, mean is 150,000. So that's why we have to consider mu is 150. Right now we cannot consider the unit, that is 1000. The standard deviation is represented by sigma, that is 15. So let's deal with the first option when x is 125. Remember, in first option we are interested to find out how many branches have the sale between 1,25,000, that is our first value. Left bound of the interval is 1,25,000. So definitely it exceeds the original value of x, that is -3 to 3. So we cannot predict or we cannot collect the value of x when is 1,25,000 from the standard normal table. That's why it's a need to apply the Z transformation. So let's see how we can apply the Z transformation. So when x is 125,000 and we know that the transformation Z is equivalent x minus mu upon sigma. So value of x is 125, mu, that is mean is given in the question is 150. Sigma, standard deviation, that is data how much variate, is also given, say 15,000. So we have to write down 15. So by solving this we have to get the value of Z, that is negative 1.66. And you may be realize that the Z falls the value which is our required interval, that is beyond the interval -3 to 3, because it takes the value negative 1.66. And the same thing when the upper bound of x, that is 145. So again by using the same transformation, that is Z is x minus mu by sigma. So plug in the value of x 145, value of mu 150, sigma 15. we have to get the value of z, that is negative 0.33. So again you have to say both the upper bound as well as lower bound of x falls within the interval minus 3 to 3. So these are the main purpose to apply the z transformation. And now the same area under the curve is shown in this z distribution table. And we are interested to find out this shaded area, that is the value of z is approximately minus 1.66 to z equal to negative 0.33. So area between, what we have to done to find out the area of this portion, we have to use some of the basic property of z distribution. We know that the total area of this normal distribution is unity, that is 1. That is half portion, left hand side portion area is say 0.5. So to find out the area of this particular shaded region, instead of that we have to find out the area of the region say z equal to 0 to z equal to negative 0.33. But again we have to use one of the property. There is nothing like say negative value in the z distribution. So instead of find out the area between say negative 3, that is minus 0.33 to 0, instead of that we have to find out the area between the curve say 0 to 0.33 by using the half of symmetry. So we have to find out area between z equal to 0 to z equal to 0.33. Then we have to take a half of standard normal table, and you have to see we have to collect the value. So area between z equal to 0 to z equal to 1.67 is 0.4525, and the area between z equal to 0 to 0.33 is say 0.1293. So right now just remember this value 0.4525, 0.1293. Now later I have shown you how you can pick up from the standard normal table. So ultimately we have to write down the mathematical formulation. So probability of z falls in the interval negative 1.66 to negative of 0.33 is equivalent to 0.45 minus approximately 0.12. So it leads say 0.32. So finally we conclude that the number of branches having cell between 125,000 and 145,000 is equivalent. There are total say 555. So we have to multiply say 550 into say 0.32. So it leads the value 178. So we conclude that therefore the number of branches, there are total 178 branch, that cells is falls between say 125,000 to 145,000. Now next I will show you how we can take the value of z 0.4525 and 0.1293 from the normal table. So see here, these are the standard normal table, and we are interested to take the value of 0.333. So we have to highlight say 0.3 on the first column and 0.03 on the first row, and we have to find out say corresponding point of intersection, and we have to take the value 0.1293. That shows the area lying between say 0 to 0.33. Similarly, we have to take the value of 1.67. 0 area falls in the interval 0 to 1.67, and it shows the 0.4525. Let's deal with the second option. In second option, we are interested to find out, say the cell is fall in the interval say 140,000 to 160,000. So the lower bound is x is 140. So we have to plug in the value of x 140, mu 150, and standard deviation 15 in the z distribution. So again you realize that the value of z is negative 0.67. That is falls in the interval say minus 3 to 3. Similarly for upper bound say x is 160, so just plug in x 160, mu 150, sigma 15, it gives the value of z is 0.67. And now we have to show the area under covered by the Z distribution in this graphical representation. So our interest is we have to find out the area of this shaded region. So again we have to use the probability. Instead of find out the area between negative 0.67 to 0.67, just we have to find out the area of say Z equal to 0 to Z equal to 0.67, and we have to use the property say Z distribution is symmetry. So whatever area covered by say Z0 to Z.67, we exactly multiply by say 2. So same thing is reflect. So 2 into probability of Z falls in the interval say Z0 to Z.67. So 2 into, next I will show you how we can collect the value. So probability of Z, so between 0 to 0.67 is equivalent 0.2486. I will show you in the later slide. And simplification leads is the probability of Z falls in the interval say 140 to 160,000 is 0.49. So see here, say 0.6, 0.07 highlights, so it shows the probability of Z falls in the interval say Z0 to 0.67 is 0.2486. So finally we conclude that the number of branches having cells between 140,000 to 160,000 is equivalent to 550 into 0.4972, so is exactly equivalent to 273. Let's see one more example. Assume the mean height of children to be 69.25 centimeter with a variance 10.8 centimeter. So the information tells that the normal height of children is approximately say 69 centimeter and variance is 10.8. So variance is 10, so standard deviation is something like square root, positive square root of this 10.8, so is roughly 3 point something. So we have to say that the normal height of the children is 69 minus 3 point something and 69 plus 3 point something. So we have to say that this falls within the interval say 66 to 72 approximately. We are interested to find out how many children in schools of 12,000 would you expect be over 74 centimeter tall. So we are interested, say any of the particular school has say 1200 children, and we are interested how out of this 1200 children, how many children would you expect whose height is say over 74 centimeter. So let's start the solution. Let the distribution of height, first of all we have to assume this thing. The height of the students is follow the normal distribution with the mean 69 point something 25 and the standard deviation, that is positive square root of variance, that is positive square root of 10.8, so it's let's say 3.28. So again we are interested to find out the how many students heights is exceeds 74. So definitely 74 is does not falls in the interval minus 3 to 3. That's why there is a need to apply the Z transformation. So we have to consider the Z transformation x minus mu upon sigma. So just plug in the value of x 74, mu is 69.25, standard deviation is approximately 3.28, so it gives the value of Z say approximately 1.44. So our interest is we have to find out what is the probability of Z when is greater than 1.44 is exactly equivalent to the probability of students whose height is greater than 74 centimeter. So these are the graphical representation, and we are interested to find out the probability of this shaded region, that is the right hand side of the line says Z equal to 1.44, that is Z greater than 1.44. So definitely is an unbounded area. So again we know that the area of this right hand side portion is 0.5. So what we have to done, instead of to find out probability of Z greater than 1.44, we have to find out the probability of Z 0 to 1.44, and whatever probability we have to obtain, we have to subtract from the 0.5. So it gives the desired results. So probability of Z greater than 74 is exactly equivalent to 0.5 minus probability of Z 0 to 1.44 and is 0.4251. I will show you in next slide how we can pick up this value from the standard normal table. So just remember 0.4251. So its leads 0.0749. So we have to say that the expected number of children whose height is over 74 centimeter out of this 1200 children is equivalent 1200 into the probability, that is 0.07 approximately. So it leads say 90 children out of these 12 children whose height is over the 74 centimeter. So see, we have to collect the probability of Z fall in the interval 0 to 1.44. So we have to highlight 1.4 as well as 0.04 and its probability is 0.4251. So thank you so much for paying your attention.